Lesson 3.1, Solving Quadratic Equations. Our essential question, how do you solve a quadratic equation by graphing and algebraically? So first let's look at solutions to a quadratic equation. What is a solution? The solutions to a quadratic equation are the points at which the function intersects the x-axis. So we are looking for specifically where it crosses the x-axis. This is also known as a zero. If I ask you to find the zeros, I'm asking you where it crosses the x-axis. These are also called roots. So if I ask you to find the roots, you are looking to see where it crosses the x-axis. You are also looking for x-intercepts. All three of these terms are another way to ask, where does it cross the x-axis? And there are three different ways that you could see it crossing the x-axis on a graph. And there are three different categories of solutions. If you have two solutions, then you are crossing the x-axis twice. This is the x-axis, this is the y-axis. An example of crossing the x-axis twice would look like this. So you cross the x-axis once right here and once right here. You have two solutions because you cross the x-axis twice. Well, what if I only wanted to cross the x-axis once? If you touch it and then run away, you cross the x-axis once and you cross it right here. That is one solution. Well, what if we had no solutions? If you have no solutions, then it does not cross the x-axis at all. It does not touch it, and so you have no solutions. So our first example, find the solutions to each quadratic equation by graphing. I have to graph it to find my solutions. I see that I have an x squared, an x, and a non-x. So this is in standard form. And in the previous chapter, we learned how to graph in standard form. First, we had to identify our A, then our B, and then our C. After you have identified your ABCs, we then had to find the axis of symmetry. The equation for the axis of symmetry is the opposite of B all over 2 times A. So negative 2 all over 2 is a negative 1. So my axis of symmetry is at x equals negative 1. So my first task is to graph my axis of symmetry. So negative 1 is right here. So here's my axis of symmetry at negative 1. Once you find the axis of symmetry, you need to find the vertex. To find the vertex, you are solving for f of x. And you are solving for the x we just found because the vertex has to live on this line. So we now are looking for f at negative 1. F at negative 1 gives me a negative 4. So my vertex is at the coordinate point negative 1, negative 4. Negative 1, negative 4 is 1, 2, right there. Because it's in standard form, the next one that you do is you look for the y-intercept. My y-intercept is C. So my y-intercept is at the coordinate point 0, negative 3. Crosses the y-axis at negative 3. If he crosses there, the axis of symmetry, there is also another one away. So I cannot just connect these and be done. I am looking for the solutions, which means I need to know where it crosses the x-axis. I currently have no idea where it crosses the x-axis. So we need to make an xy table. You said at negative 1, I had negative 4. At 0, I had negative 3. The next is at 1. So when I plug in 1 to this equation, I get the point 1, 0. So I know it crosses right here at 1, 0. He is 2 away from the axis of symmetry. So his partner is also 2 away from the axis of symmetry. I can now connect my quadratic function, my parabola, and my answers are where it crosses the x-axis. I see that it crosses the x-axis in these two spots. I'm going to use whiteout to give myself some space so you can see. So I know where I cross the x-axis is my solution. So this is my y-axis. So this is the number 1. So x crosses at 1. Here's the y-axis, so this is 1, 2, 3, and that is x at negative 3. So my solutions are x is negative 3 and x is a positive 1. It crosses at those two spots. So practice problem number 2. I'm having a hard time actually seeing where the x and y axis are, so I am going to make their lines darker. So this is my x and y axis. we need to graph this quadratic function. Because it's an x squared x, no x, I know that this is in standard form. And if it's in standard form, I needed to identify my A, my B, and my C, so that I could now find my axis of symmetry. So axis of symmetry is the opposite of B all over 2A. So my axis of symmetry is an opposite of negative 10. So I have 10 divided by negative 2. So my axis of symmetry is x equals negative 5. So I need to color in where I found x to be negative 5. So this is my y-axis. So this is 1, 2, 3, 4, 5. Here is my y at negative 5. Here is my x at negative 5. So that's my axis of symmetry. After you've found the axis of symmetry, we need to now find our vertex. To find your vertex, you are going to solve for the function on that axis of symmetry line. So f at negative 5 gives me 0. So my vertex is the coordinate point negative 5, 0. Negative 5, 0. So negative 5, 0, my vertex sits right there. My C, my y-intercept is the C, which is a negative 25, which is way down here. So way down here. I already touched the x-axis, so I'm going to go ahead and graph it. And because I already touched the x-axis, I already found my answer because I was just looking for where did I cross the x-axis. And that crossed it, so this is my y-axis, 1, 2, 3, 4, 5. This was where x is negative 5. So the solution to problem number 2 was x is negative 5. I want to skip number 3 for now. This is going to be assigned for you for independent practice. I also want to skip number 4 for now because this will also be assigned to you as independent practice. I want to do problem number 5. I see an x squared and a non-x. This is in standard form. But we have a particular part missing. Standard form is supposed to have an x squared and then an x and then a non-x. So this is in standard form. We just happen to have 0 x's. So here it is in standard form, which means I need to identify my A, my B, and my C. So for my axis of symmetry, x is the opposite of B all over 2 times A. X is 0 divided by 2 is 0. So my axis of symmetry is where I cross the x-axis at 0. I cross the x-axis at 0 right here. So this is my axis of symmetry. Oops. This is my axis of symmetry. Now I need to find my vertex. You find your vertex by solving for the axis of symmetry. So I'm going to solve this equation at 0. So f at 0 is a negative 9. So my vertex is the coordinate point 0, negative 9. So there's my vertex. I need to find my y-intercept. My y-intercept is where I cross the y-axis. It's the C. It's negative 9, which just happens to also be my vertex. They are the same point. Well, now I need to find my other points, which means I need to do my xy table. My vertex was at the coordinate point 0, negative 9. So after the 0, I need to do 1. So plug in the 1, I get negative 8. So I get 1, negative 8, and he has a partner. 1 didn't get to the x-axis, so now I got to try 2. Plug in 2, I get negative 5. So 2, there's 2, negative 5. He's 2 away from the axis of symmetry, so his partner is also 2 away. I still haven't reached the x-axis, so now I got to try 3. Plug in 3, I get 0. So I've got the coordinate point 3, 0. He is 3 away from the axis of symmetry, so his partner is also 3 away from the axis of symmetry. I finally reached the x-axis, which means I'm finally done with this problem. So connect it into a nice smooth U shape. And where you cross the x-axis is your solution. We're only worried about where we cross the x-axis. So here's me making a blank spot so I could write my answers. This is the y-axis. So 1, 2, 3, I crossed at x equals 3. Here's the y-axis, 1, 2, 3, I crossed where x was a negative 3. So I found my two answers because I crossed the x-axis twice. This was problem number 5. So the two answers for problem number 5, x equals negative 3 and x equals a positive 3. Problem number 6 is also in standard form, you're just missing the c. So I have x squared x, I'm adding 0, now it is in standard form. So please finish problems 3, 4, 6, and 7 for independent practice.